ClassEval-Pro is a new AR14 paper for coding agent builders. The key idea is simple. Function benchmarks are too small, repository benchmarks are expensive, and there is a missing middle. Can a model build a complete, internally consistent class from a specification? That is where many real coding agents still break. A class is more than one function. Methods share state, depend on each other, and need consistent interfaces. ClassEval-Pro focuses on compositional code creation, generating a complete class with multiple methods that work together. That is closer to product code than another isolated human eval style function. The primary source is AR14 version 1, submitted April 29, 2026. The authors introduce 300 class-level tasks across 11 domains, and the GitHub repository confirms the benchmark description while noting that the full dataset and evaluation code are coming soon. The construction pipeline starts from GitHub Python repositories created on or after January 1, 2025. It filters self-contained classes, composes same-domain and cross-domain tasks, generates tests, uses an LLM judge ensemble, and keeps tasks only when reference solutions pass with at least 90% line coverage. Out of 300 tasks, 233 are cross-domain and 67 are same-domain. The largest buckets include finance and e-commerce, file handling, management systems, network and web, database operations, and security and crypto. That matters because production coding rarely stays in one neat category. Compared with the original ClassEval set, ClassEval-Pro increases average lines of code, dependency depth, and method count. Cross-domain tasks average about 117 lines and roughly 9.5 methods. The benchmark is asking models to maintain structure across a whole class, not just fill in a short helper. Under holistic generation, the best source reported class-level pass at 1 is 45.6% from Qwen 3 480B A35B, with Kimi K2 and Gemini 2.5 Pro close behind. GPT 5.1 is reported at 27.9%. The point is not to dunk on one model. The point is that class-level composition is still unsolved. The paper tests holistic, incremental, compositional, top-down, and bottom-up strategies. Structured decomposition can help weaker models by up to 9.4 points, while compositional generation can collapse as low as 1.3% in one setting. For builders, that means your harness design is part of the benchmark. The authors manually annotate 500 failed cases. Logic errors make up 56.2%, and dependency errors make up 38%. Syntax is almost gone. The bottleneck is whether methods coordinate correctly across shared state, dependencies, edge cases, and interfaces. My takeaway: ClassEval-Pro is useful because it points evaluation toward the work agents actually need to do. Build class-level tasks, require tests, track coverage, separate prompt strategy from model capability, and measure failure modes. When the dataset and code land, it should be a strong candidate for coding agent harnesses and software factory evaluations. Subscribe to Fluid Coding and AI for grounded model releases, coding agents, and software factory builds.